Hello everyone. Integration by parts. Tabular method. Usually we use the integration by parts when you have a product of two different functions. Function we name the first function u, the second function we name it dv. Like this function. Integral of x squared cosine 3x. This is a polynomial and this is trigonometric function. Okay, the rule used here, integral u dv is equal to uv minus integral v du. We usually select the function u that easier to be or easy to be differentiated, and the dv it's easy to be integrated. I have example here to use the tabular method. The relation between tabular method and integration by parts, this is the main way or method to use. Tabular method means applying integration by parts many times. How does it work? Let me show you. The integral of x squared cosine 3x equal dx is equal to. I just make a little table here. The u and here dv. The table consists of the first function, the u is x squared, the original function you have in the integral, cosine 3x. The function u you continue to derive. Derivative of 2x is 2x. Derivative of 2x is 2, and derivative of 2 is 0. Okay? The integral of cosine 3x, the integral of cosine is sine 3x divided by coefficient, or derivative of 3x is 1/3 or 3. The integral of sine is negative cosine, so negative 1 over 3 times 3 is 9, and cosine 3x. And finally, the integral of this one corresponding to 0 is integral of cosine, as I said, is sine, so negative 1 over 3 times 9, 27, sine 3x. The integral I have now, the integration of x squared cosine 3x is equal to, just multiply this by this, okay, plus this by this, plus this by this, 3, okay. We reach 0 now. Here the integration of 0 is nothing, is a constant. Okay, so don't forget to write the positive here. The original integral is positive. Just write positive here, and then negative, and positive, then negative. These signs related to the rule here used, the integration by parts, uv minus integral v du. So the integral I have is 1/3, just multiply this together. 1/3 x squared sine 3x, negative and negative is positive, plus 2 over 9 x cosine 3x, and finally minus 2 over 27 sine 3x plus c. Okay, this is the answer. 1/3 x squared sine 3x plus 2 over 9 x cosine 3x minus 2 over 27 sine 3x plus c. This method is called the tabular method. The word tabular comes from making a table like this between u and dv. Okay, another example. Find the integral of x squared e to the x. Also form a table, as I said now. This is derive this function and integrate this function. The derived function is x squared, the integrated function is e to the x dx. Okay, now write the function x squared here and e to the x here. Look, this is the u and this is dv. So derive x squared is 2x, deriving derivative of 2x is 2, derivative of 2 is 0. The integral of e to the x is the same, e to the x. The integral also, again, just you continue this way by integration, continue this way by derivative, d by dx. Okay, here, and this is the way we do it here. E to the x is the same and e to the x is the same. Once you reach 0, this is stop writing the table, and the integral equals, just multiply that. Don't forget to write the sign of the rule, positive, negative, okay? Just multiply, very easy. The integral is x squared e to the x minus 2x e to the x plus 2 e to the x plus c, the constant of integration. Very easy. So this table really summarizes the methods of integration by parts in a simple way. Okay? Really, this is the original way to calculate the same question, but this is the normal way to calculate by integration by parts. Integral x squared to the x. Take all these steps. I applied integration by parts once and then applied again to the remaining part of the first step. Then I collect the answer in this. And instead of all of this, I used the tabular method. It reduces the steps by about 50%, as you see. Continue solving this one, a different question. Here also you use the table here. This is D. Some teachers name it the DI table, no problem. Just write here e to the 2x and here cosine x. Okay? Continue driving here. Here driving, here integrated. Drive this one is 2e to the 2x. Drive again, 2 times 2 is 4, e to the 2x. And once more, 2 times 4 is 8, e to the 2x. Integral of cosine is sine x. Integral of sine, negative cosine. And integral of cosine is sine, but you have a negative sign here. Okay? As you see, this table is not reach 0. Here, continue e to the x will remain to the infinity. Also here, like alternative function, sine, cosine, without end. In this way, you stop now. You will multiply the first one here. Don't forget the sign, positive, negative, and negative. Try to get a line similar to the first one. This is e to the 2x cosine x. This is sine, this is, yes, look at this one. The same function, cosine, the same function here, e to the 2x. You have coefficient, no problem. We will stop here because this is the same. The function is recurring. The function you want to integrate, you will see it again in the steps of your solution. So stop now and write the answer in this way. The integral is equal to multiplying this e to the 2x sine x, negative and negative is positive, 2e to the 2x cosine x, this, plus this one. This is the last line here, plus this one. I have a negative 4e to the 2x cosine x. I show you now why I do this. The answer equals e to the 2x sine x plus 2e to the 2x cosine x. This one really, sorry, this is the last one is integral. This second part of the function. Don't forget this part. This part that's subtracted in the rule is the same horizontal line here. This is the remaining because the table is continuous to infinity, no end for this table. So I'll say minus 4, this one, integral of this one. I just take 4 outside. Really, this one, the integral of e to the 2x cosine x is the same original function I want to integrate. Yes? Yes, the same. E to the 2x cosine x, e to the 2x cosine x. Name this is I. This is I, the same function I want to integrate. Okay? By adding 4i to each side, adding 4i here, you will get now I plus 4i is 5i is equal to e to the 2x sine x. Don't forget plus c here, constant of integration, plus 2e to the 2x cosine x. Here is 0, plus c. So the original integral now is simply 1 over 5 into, just multiply by 1 over 5 each side, by 1 over 5 here, all this side, and then this by 1 over 5 also, this side. So the final answer is 1 over 5 e to the 2x sine x plus 2e to the 2x cosine x plus C. Consider this one is C1. 1/5 a constant time constant will be also constant. Don't write 1/5. Oh, you can write 1/5 C1, but simply it's really another constant. This is the answer. So the integral equal 1/5 of this expression plus C. Okay. The last one I want to show you, our last example I have, this one. The integral of e to the 2 theta sine 3 theta. The same way here, by using tabular method, the derived function here, integrated function here, I have e to the 2 theta, its a derivative 2e to the 2 theta, derive again 4e to the 2 theta. I have here sine 3 theta. Integration of sine is negative cosine, negative 1/3 cosine 3 theta. The integral of cosine is sine, so negative 1/9 sine 3 theta. Okay. Also, as you see here, is not will continue to infinity. Look, I reach the line the same, including the same function here. Look, e to the 2 theta cosine 3 theta, sine 3 theta. You stop now. Don't continue. Just multiply. Don't forget to put a sign, positive, negative, and positive, and multiply this way, plus last line, integral of the last line. So the integral I have here, I is equal to, multiply with me now, negative 1/3 e to the 2 theta cosine 3 theta. Okay. Negative and negative is positive. 2e to the 2 theta, 2/9, really, negative times negative, 2 times 1/9, 2/9, e to the theta sine 3 theta, okay? And finally, minus the integral of, I can multiply 4 times outside, 4/9 here outside, the integral of e to the 2 theta sine 3 theta, okay? This is really d theta. This part is really the I, the same function I want to integrate. Okay, so name it I and bring a 4/9 on the other side. So here I plus 4/9 I in this side is equal to negative 1/3 e to the 2 theta cosine 3 theta plus 2/9 e to the 2 theta sine 3 theta. Don't forget to add a constant of integration here. Okay. I plus 4/9 I is equal to 13/9 I. Just add 1 plus 4/9 equal negative. I can arrange this one to be easy, and I can take, look, e to the 2 theta is the same. I can take it outside, e to the 2 theta here. Remaining inside here, 2/9 sine 3 theta. Of course, it's better to start with the positive part of the function and leave the negative part in the next one. Negative 1/3 cosine 3 theta. But if you keep the same order, no problem. It doesn't matter, of course. Finally, multiply each side by 9/13 to get the I subject. Multiply here by 9/13. Multiply whole this by 9/13. Okay. And also you have simplification. You can do it here. 9/9 is cancelled out. So you have, you can keep it outside here. So 1/13 e to the 2 theta multiplied 9, keep 1/13, only multiply 9 inside. 9 inside will be 9/9. 1 will be 2 sine 3 theta minus 9 times 1/3 is 3 cosine 3 theta, okay, plus a constant time. This is the same constant, so will be also C. You can say this one is C1 and this is only C. Okay, so this is a summarization for the using of tabular method. It reduced the work of normal way of integration by parts to the minimum part of steps you can do. Thank you so much. I hope everyone to got the idea, and see you next time. Goodbye.